Question 1 is, an engineer is interested in testing the bias in a pH meter. Data are collected on a meter by measuring the pH on a natural substance, which is 7. A sample of size 10 is taken with result given by the number of below. So we need to calculate the mean and standard deviation of the sample taken. To get the answer of mean, first we need to pass all the number of given and divide with tens. So we get the mean 7.025. And before calculate the standard deviation, we need to calculate the variance first. So the variance we get here is 0.001939. And now we can calculate the standard deviation using the square root of 0.001939. So we will get the answer, which is 0.044.
For question 2, we will solve the problem involving drawing cuts from a deck. So we will drawing 3 cuts in succession without replacement, and we will calculate the probability of 3 specific events happening together, which are: the first event is the first cut must be read as, the second event is the cut must be 10 or a check, and the third event is the cut must be greater than 3 but less than 7. So to calculate the probability of drawing read as we know, in a deck there are 52 cards in total, and 2 of them are red S's. So the probability of the first event is 2 over 52, and if we simplify we will get 1 over 26. Okay, after drawing a red S, there are now 51 cards left. So second card, we need it to be 10 or a jack. So there are 4 tens and 4 jack in a deck, which make it 8 cards in total. So the probability of A2, given that A1 has already happened, is 8 over 51. After the first 2 cards have been drawn, there are now 50 cards remaining. So the third card must be greater than 3 but less than 7. So this includes card 4, 5 and 6, and each of them has 4 cards. So there are 12 cards in total. Therefore, the probability of A3, given that A1 and A2 have already happened, is 12 over 50. And if we simplify, we will get 6 over 25. So to find the overall probability, we need to multiply the probabilities of the individual events together. And after we multiply, we get 8 over 5525.
Okay, so question number 3, we are aimed to find the probability distribution of the number of defective microcomputers in a random purchase of 2 out of 8 microcomputers where 3 are defective. So let's assume let X as represent the number of defective microcomputers in the purchase. The possible values of X will be 0, 1 or 2. The first step would be to find the total number of ways to choose 2 microcomputers from 8, which will be 8 times with 7 per 2. Then we will get 28 for this. Next, we need to find the number of ways to choose 2 non-defective microcomputers out of 5. It will be 5 times with 4 per 2, we will get 10. Then we need to find the probability for this case. Px equals to 0. 5 2 per 8 2. We will get 10 over 28. Simplify that, we will get 5 over 14 for this case. That is the probability. Next, we need to find the number of ways to choose 1 defective microcomputer out of 3 and 1 non-defective microcomputer out of 5. That will be 3 1 times with 5 1. We will get 15 for this. Then find the probability for case 2. We will get 15 over 28. The last step would be to find the number of ways to choose 2 defective microcomputers out of 3. 3 times with 2 per 2, we will get 3 for this. Next, find the probability for this case. 3 over 3 2 per 8 2, we will get 3 over 28. To summarize the probability distribution, x for 0, the probability will be 5 over 14. For 1, we get 15 over 28. For 2, we get 3 over 28. That's all. Thank you.
Question 4. The probability that a patient recovers from a rare blood disease is 0.4. If 15 people are known to have contracted this disease, what is the probability from 3 to 8 survive? So for the question 4, we may conclude that it is the binomial distribution. So we'll using the NCX P power of x Q power of n minus x. So for n, it is 15, P is 0.4, Q is 1 minus 0.4, and x is the survivor patient, which is 3 to 8 patient. So using the formula, we will get all the number for each surviving patient, and then we will make sum up, it will be 87.78%. Question 5. 10 is the average number of oil tankers arriving each day at a certain port city. The facilities at the port can handle at most 15 tankers per day. What is the probability that on the given day tankers have to be turned away? So the question 5 is a tricky question, which is we need to determine the probability of 15 oil tankers, at most 15 oil tankers, and also the probability more than 15, which is starting from 16 and above oil tankers that need to be turned away. So using the Poisson distribution formula, we will calculate the probability of at most 15 oil tankers, and then we will get 0.65126. So we will minus it with 1, which is the probability more than 15. 1 minus 0.65126, and we will get the percentage of oil tankers will turn away is 4.87%.
So the question 6 is, gush are used to reject all components where a certain dimension is not within the specification 1.5 plus minus r. It is known that this measurement is normally distributed with mean 1.5 and standard deviation 0.2. Determine the value of r such that the specification covers 95% of the measurement. The given mean is 1.5 and standard deviation is 0.2. We assume that x is equal to measurement and the specification given is 1.5 plus minus r. Through the given information, we can create the equation x1 equal to lower limit, which is 1.5 minus d, x2 same with upper limit equals to 1.5 plus d. And we must use the given information to find the value. After finding the value, which is 0.025, we can create an equation to find the d, which is p same as z less than or equal with negative d same negative d divide 0.2 equals to 0.025. And now we need to use the z table to find the d. So from the table we find the D is negative 1.06. So D is equal to 0.392. Then now we can substitute the D into our equation with x1 and x2.